So good morning, Rishwan. I'm going to start you off with the first unit today.
Okay,
Just
great.
back on the 5th. So obviously I'll cover this unit up with you because this is a bit of a generic and a very basic unit that we have in the level 4 qualification. Now this unit is basically computer systems and software. We're looking at unit 2 learning outcomes. This unit really slightly outdated. So what I thought was, when I say outdated in the sense is, the content which is being asked to cover in this unit is continuously evolving. So what we have seen is that when we talk about computer systems, actually computer systems have evolved. But what I'm going to try and do is obviously refer to one or two YouTube videos to try and bring up some of the key concepts which are now coming into when we say a computer system. The aim of the unit is primarily to help learners who are going on to the IT qualification understand really what are the components of hardware and software, and when we look at a computer system. Now, computer system is a very generic term. When we started off, way back in the early 80s, in the 90s when Windows came out, everything changed from a DOS prompt to a graphical user interface. And then as we saw the evolution of Windows operating system happening, I think at some stage we saw the scale tilting towards software side of things, which then started to drive, the system side of things when we look at a computer system. So I think in this unit, what we want to be able to do is, look at a combination of building our foundation, understanding of how we understand what is a computer system in the old context, look at some of the basic components, and divide them into different types, things like peripherals, looking at various input-output devices, which will be also classified as peripherals. But we'll also look at some of the inner details of what does the hardware constitute and what does the software constitute. So how do we differentiate between the two? And we understand the roles and functions of hardware and software. They come together as individual components to run a package, which is basically a computer system. So the first learning outcome essentially focuses on you understanding what are the components of a computer system. The reason why we start off with this also is backed up by one of the important thing is, when you work within an IT department within a company, or take up a particular role within an IT department for an organization, what you will see is that from time to time people are required within this particular role to put together systems, and these systems sometimes are put together looking at the demands of users. So you might have people within the engineering team, within the coding programming team, which would need maybe very high or heavy duty computers wherein the processing power has to be quite good. When you look at the graphics department, again, they need systems which need to have more of graphics memory, more of RAM. And then when you look at people who work within the administration, sales, marketing, they need systems which are more connected. Access is required, in terms of shared data. And when we look at systems primarily for the management, you get to see with a bit of a trend that some of these systems in terms of display devices, or when we look at peripherals like an output, which is a monitor or a display device, you see normally larger display devices at their screen because they're more looking into not data, but information for making decisions. And that is where, you have to, when you work within the IT department, sometimes when you get this request that I need an upgrade for a RAM, or I need to get my system replaced, or my system is running slow, or it's been, I think it's running slow because there is a virus attack on it, or, it's been hacked. Those kind of things that you need to look at in terms of troubleshooting. That is where I think, from a basic point of view, any person working within the IT should be able to understand some of these systems and components quite clearly. So we've got a couple of slides here which are quite, I would say, elementary, but they give you the information which is required for you to be able to understand the the components of a computer system. And what I'm going to do during the session, try and basically show you one or two quick YouTube videos, which you can also watch offline, because what I've been able to do now is obviously put them onto Moodle, and obviously under the some of these videos which have been put out by different people on YouTube, might be slightly more updated, because when we talk about input-output devices, when we talk about peripherals, there are loads of things happening. Like in the CES in January, Samsung introduced a 49-inch curved monitor. Now that is as big as a television, but the graphics resolution on it, the GPU unit, and the reason why they've introduced this, they primarily introduced it for the gamers. They've introduced it for people who look at stock markets or trading. They want multiple monitors, multiple screens. So they've integrated that. But that's a new development. So obviously that is something which is not going to be commercially available in the market. But the idea would be to try and look at some of these developments, from a YouTube context, because these new snippets are actually put out, on that side, and there will be a bit of good, update to what is required. So what I'm going to do is go through some of the slides, and then if you have any questions, just ask me there. Now, the first thing that we look at is this is a very basic definition of what is a computer. This used to be a device when we look at the early 80s, or initially when the calculator was introduced. This was a device which was used to actually automate basic things like the abacus, which we used to have in the early, about 2,000 years back, when some of our ancestral people used abacus. The Egyptians used it. They used it as a bit of a calculator. From that concept, if you look at that, is the father of all computers, if I look at it in some rudimentary form. But as we've evolved, we see a calculator coming in, and the calculator leading to a bit of more complex calculations, which then led to the creation of computers. The computers that we see today, fit in the palm of our hand, and a smartphone that we use is also a computer to a certain extent, because it allows us to do most of the functions. But if you look at the 80s, devices were as big as the size of the room, and when they were introduced by IBM, and used to do basic coding or automate some of the basic production functions like punch cards and things like that, which allowed workers in the factories to increase output. But as the concept has evolved, what we have seen is the computers are able to, with the advent of memory, what we do see is the computers are able to kind of accept data, process it, and then store it to a certain extent and give us an output in some form. So when we look at a computer system, we define something as a device which allows us to input information, process it to a certain extent, and then store it if necessary on a device which is an external peripheral or a hardware, or internally within the system itself, and then allows us to process that information and maybe get an output in the form of print, maybe in the form of an email, things like that, and that would classify a computer system. Now, in order to understand what does it all consist of, I would primarily say, if I divide it into hardware, software, and peripherals, that would kind of make the broader classification of a computer system possible. But sometimes you'll have to get into things like input-output devices. So devices that allow you to interact with the system, things like keyboard and mouse, touchpads. There are other forms of, slates and other forms of input devices which are used in different sectors, as we call it. But at some stage, this information that you're inputting in is displayed onto some sort of a device, normally a monitor or a screen. And at some stage, whatever you're doing, browsing, emailing, doing any complex calculations, making a presentation, all that is being processed internally, and what you get to see that as an output straight away onto the screen. But if we step back early in the 80s, what that meant was that if you had to put in some information, it was put in the form of some cards or some instructions, and then it used to take a bit of while, when I say a couple of, minutes, in some cases, couple of hours for it to produce an output. And from where we see that evolution of systems happening, what we've seen is that the processing power has nearly, quadrupled every 2 or 3 years, and the storage in terms of systems is also quadrupled every 2 or 3 years. So when we break the hardware components down, there are 4 or 5 different components within the hardware. And when I say in hardware, we take up the first part, which is the central processing unit, or the CPU, as we call it, the processor. And as you see, some of the Intel processors, the AMD processors, or IBM processors, which were introduced earlier, they used to be 8-bit. Then it became 16-bit, and today we have processors which basically are at 0.5 or basically 5 nanometer process. So they have up to 1 billion transistors, which allow them to store a lot of information, process a lot of information, and obviously some components of the CPU have now, which were external, things like the graphics processing unit, things like some part of the memory, the logic, arithmetic and logic unit, were outside the processors in the early 80s. When we look at shifting to 90s, some part of that started to get integrated. But anything after post 2005, I would say, pretty much has these components integrated into the processor itself. So you have things like the memory, the transistors, which is allowing the CPU to process number of transactions in microseconds. Some part of the processor also has an inbuilt memory, as we call the cache. And at some stage, this cache has also increased. It used to be 8 KB, 12 KB. I remember the first computer that I had, 486, way back in 1994, only had maybe a floppy drive for storage, and there was no storage in the hard drive. There was nothing called a hard drive. So all the storage was on 5.5-inch, floppy disks. Slowly and gradually that gave way to 3.5-inch. Then we had the advent of hard drives, wherein it started off with 8 gig, 10 gig, 30 gig, and it's increased. Today you can get up to 256, 512 GB or gigabytes in about the size of a small, card, which is like a micro SD card or even, an SD card.
Yeah.
So some of the main components of the computer system that we look at, we need to look at understanding the CPU forms the main unit or the tower, as we call it, and that tower basically has a lot of components in it. We'll get into that, and then to the tower are connected the input and the output device. So the input device primarily being a mouse and a keyboard, as we understand, and the output being a monitor. In some cases, it could be multiple output devices when you have connected peripherals like a printer or some sort of an interface machine, scanner. It could be something which allows you to get an output in a particular format, and they will all be classified as output devices. Now, in the CPU, if we understand the processor and the breakdown of how processor works, that is something having integrated memory or cache. It has its own memory now in modern day times. When you look at the iCore 7 or iCore 5 processors from Intel, or you look at the AMD processors in particular, you look at processors today from Qualcomm, you look at processors today from ARM processors in particular, which are used in most of the white good peripherals, that white goods that we use, things like washing machine, fridges, refrigerators. You look at any other device which is classified under that, and they will have some sort of a processing unit. Now, that is an integrated processing unit, but if we go back to the computer system, you look at a Mac or a PC, the classification across, because of the fact that they run different softwares and have different hardwares, they have some basic components which are similar and common within the CPU or the tower, as we call it. And within that tower, you have something called the control unit. You have the arithmetic or a logic unit, which is basically also a processor. And this has also now been broken down into something called the graphics processing unit, GPU. We have memory, we have a system or a motherboard which has lots of components soldered on it, and that is the main assembly on which most of these most of these peripherals are actually integrated within the tower unit. So you have a memory slot, you have a power unit, you have something called a slot for the processor, you have slots for input-output devices, you have slots for primarily transfer of data, memory, and loads of other things which are things like audio, sound card, audio input-output, and other things that you can think of, things like which allow you to put in peripherals like a flash drive, USB ports, and all these things are a part of the tower. Now, why do we want to understand this? I think it's very, if I am studying IT, which I've done earlier, because one of my majors in this field was in HND in IT. Now, I was able to put together a computer system. So if you remember Dell's model of, when they launched and it came out in the market, they were a new concept in the early 2000s, late 1990s, wherein you could actually order a build to configure PC on their website, and that PC would arrive to you. Could be once you pay for it, you configure it. You could get that PC in 3 to 4 working days, or 4 or 5 working days. depending on the location. Right. Now, at that point in time, this concept was very important, is because, and even today, when we work as hardware engineers, or when we work within the IT department, we need to be able to be comfortable with understanding what are the components, how to put them together, how to take them apart, and then obviously if I have designed, and when I say designed, I have put together, assembled, not designed, I put assembled, computers myself, wherein given the IT department, way back in 1996, where I worked in HCL, sometimes you have to put together your own system. So there were memory banks available, there were hard drives available, there were CPUs available, there were all sorts of motherboards and components available. And then at that point in time, what you could do is basically because I had the knowledge of IT and hardware, what we could do is basically put it together. So the only bit that you required a bit of help on at that point in time when I was a novice was how to, look at wiring, how to look at, connectivity. But today, most of the systems that you buy from the market, if you're a person who's studying an IT course, you should be in a position to be able to put together a PC or a tower of your own configuration. So towers are available, which come with the power unit, or you can choose a type of a motherboard. If you're putting together a gaming PC, or a high-end PC, or a PC which is normally going to be used for data processing or graphics use, you pick up a graphics card, you pick up a heavy-duty motherboard, power supply, type supports that you want to integrate in terms of input-output devices. Choose a processor, the memory in terms of configuration. Most of them are now available sizes of 8, 16, 32, 64 gigabyte. And you put that together, you install the basic BIOS of the system, which comes on the motherboard, boot it up, and there you go, you at least have the basic system. And on top of it, you install the software. Now it could be PC, it could be Mac, but generally if you're putting together a component system, we are talking about a PC here, because Mac configurations primarily tend to be very different, and you have a good knowledge of Linux or a different type of an operating system which is required to control or program the kernel. So when we look at understanding this particular learning outcome, we are looking at understanding the components. So starting off with the tower unit, go into something called the memory types. We used to have, when I say we used to have, we still have what is called the primary memory and the secondary memory. So the primary memory, which is basically to do with the fact that it is talking about the RAM or random access memory, and we will look at secondary memory. In main memory also, we have something called the ROM, which is a read-only memory. So in the old computers, we had only something called the ROM, and that ROM essentially meant that, we had, once you switch off the PC or switch off the computer system, whatever data, if it's not been stored or saved, gets lost. But some of the ROMs, when it started to come out, had instructions which were, encoded into it. So even after the system was switched off, instructions were not lost. And some part of this data which was put into the ROM was primarily programmed to boot the PC, or when we look at the BIOS in particular. Then came the concept of RAM, which basically meant that there was enough, there was a whiteboard or a blackboard kind of a memory which was required for the system to expand and keep running some of the software side of things in order to provide speed and efficiency. And they were classified as something called random access memory. And at some stage, I think after the 1990s, 95, 96, when hardware storage, or storage as we call it, the secondary storage became affordable, Seagate, we know some of the companies like Seagate, Western Digital, we look at firms like Samsung, when they started to introduce, something called storage devices. They started off coming in different configurations, and that allowed us to basically store the material, permanently on the computer system. And that is where, you look at the division of memory starts to happen, which is basically saying main memory. In main memory, you have read-only memory, and then you have RAM or random access memory, which is a temporary memory, which is required while the system is up and running, and the secondary storage, which basically allows you to, back up or, store data. And that used to be primarily, primarily what you call, the 3.5-inch, 5.5-inch storage devices. And then after that, it led to the creation of something which was the, hard drives, And in the early 2000s, we see the concept of, flash drives now coming in, and flash drives have started to also increase in storage. Now, when we look at ROMs in particular, there are 2 or 3 different types of ROM, and there was something called the programmable ROM. That means you could program a set of instructions into it, and those could be stored permanently, and that they were part of, smaller instruction sets which were embedded into things like the motherboard, the power unit, the graphics unit, which allowed them to be started or, interact with other systems when they were integrated, in order to, work as a coordinated system. So when you switch on the PC, you see a number of, I don't think you see that happening now because, but if you go back a couple of years, when I say couple of years, maybe 1 or 2 decades back, when DOS was primarily present, you had this booting process. When you switched on the tower, it went through a lot of instructions, kernels, check of memory, checking the systems were okay, input-output devices are connected. But as the time has progressed, what has happened is all this is still happening in the background, but it's happening now in milli or microseconds. But back in those days, you could see that programmable ROM, when you switch it on, it starts off, runs a set of instructions, then basically boots the system, the power, the input-output devices, the display, and then you had a kernel or a DOS prompt coming in where you could actually, put commands. So ROMs are still very important, but some part of this ROM is actually now integrated into the CPUs itself when we talk about the processor, the graphics processor, and these are then running certain set of instructions, primarily to, activate that device to be able to communicate with other systems installed in the computer system. Yeah. Is that okay? Now, in terms of, secondary memory, the evolution of secondary memory is happening from magnetic tapes. So even before we had the floppy drives or the disks, we had magnetic tapes, and all these set of instructions were actually stored onto the magnetic tapes, led to the evolution of 5.5-inch floppy drives, 3.5-inch floppy drives, then hard drives, and today what we have is, something called the, flash drives, which kind of mimic, the floppy drives because they are what is called the, replaceable or transportable memory. So if you want to carry some instructions across, what you do is you put it on a flash drive and you take it out, and then wherever you go, plug into another system, and you still have access to that data. The modern day concept of that is cloud computing. So you store everything in things like Dropbox, Box, various type of storages like Google Drive, and what tends to happen is wherever you log in, you have access to the internet, you're able to basically get the access to that data pretty much, from where you left. So similarly, there was something which was invented, and CD-ROM drives were also optical storage, as they were called. And in the early 1990s, they were one form of storage which, let's put it this way, when you couldn't store data much in, you wanted to have data which could be mobile, but you also wanted that data to be reused again and again without having to boot the PC or have it work on different peripherals like a DVD player or, some sort of a VCD player. Then the concept of CD-ROMs came about, and CD-ROMs have also undergone an evolution wherein it was only read only once. That means once you burnt the data onto a drive, it was not reusable. So you could reuse the data which was on that drive, demos, or when you used to look at, visiting large exhibition events, shops, if there were demos being run, adverts being run, they used to be programmed onto something called CD-ROM drives. After that came the concept of DVD-ROM, wherein you could, have more capacity, but also had the ability to be able to rewrite and reprogram that data. So the type of data in terms of its resolution, capacity, and, the quality improved. And that is where CD-ROM had a limitation of 640, I would say, megabytes of data which could be stored initially. But then we had CD-ROMs which were CDRs. That means they were recordable. And they had 2 layers, front and the back. Both of them could record data, and that took the capacity up. But at some stage, then they were rewritable, which was introduced. That means you could reuse the same media again and again to, write new material on it, or write or store new data or information on it. And the same concept evolved with something called DVD-ROMs. You see CD-ROMs and DVD-ROMs today in PCs?
It's very rare that you do.
It's very rare now. I know that some of the Macs I've also done away with, the CD-ROM and the DVD-ROM drive. CD-ROM, I think, disappeared in the early, I would say, 2004, 5, 6. But DVD-ROMs were still prevalent till about 2012, 13. But any lineup that we see in terms of PCs coming out from Microsoft and some of its related manufacturers, Microsoft is obviously not producing the hardware, but when we look at a lot of manufacturers like Acer, HP, Dell, Lenovo, you look at, Samsung, some of the others in the Far Eastern side like Fujitsu, NEC, they still have maybe the option of configuring a drive, but they are more dearer to have on the machine than have maybe twice the size of hardware storage that you want in the devices. But sometimes some machines in the office, when you are in IT, you will always have a legacy system, and that legacy system will have some of these technologies because some data, some information which has been stored on a legacy device like a CD-ROM or a DVD-ROM will still need to be read, and that is where sometimes in the IT department you look at, they also have an old PC and an older PC which allows them to look at dealing with some of the data information which is available in legacy drives, and maybe as a memoir, some companies still have it. Now, when we look at types of memory, what we want to be able to do is understand how this concept of the storage originated. So it started off with something called a bit, which was the smallest addressable storage unit, and it was, when we look at binary, when we say in computers store information in binary form, which is either a 0 or 1, and that's an abbreviation for a bit. Then the bit was expanded to something called a nibble. Bit was one set of information which is either a 0 or a 1. So if I have to write, say, my name and store it on the PC, it does not get stored as Raman, but it gets stored in a combination of zeros and 1, and that is how the memory actually understands and stores all the data instructions which you ask, which you save on a PC or on a computer system. It led to the creation of Nibble. Nibble was half a byte, and this was non-addressable unit of memory. That means once it was created, it was stored permanently. It then led to the evolution of byte, something called word, double word, and as the number of as the sets of instruction which could be stored on the PC or the computer system increased, the measuring unit in terms of measuring memory also has increased and evolved over the years. So it started off as bit, nibble, went into byte, word, and today you have something called a double word, which is about 32 bits, and then they were prevalent in these 386, 486 processors. But if you look at today, the ones that we normally use, we use gigabyte or terabytes essentially, and here the number of bits they are able to store in terms of data or information has, as you can see, it's quadrupled every couple of years. And today what we see is gigabytes or terabytes, and 1 gigabyte is equal to 1024 megabytes. You look at 1 megabyte, which is equal to 1024 bytes. Kilobytes, 1 kilobyte is equal to 1024 bytes. Is that okay?
Yep.
Yeah, very simple, something which you are aware of. And this is what we are actually using today. So if I have a Dropbox, if I have, a storage device, normally we're looking at 1 terabyte, 2 terabyte, 5, 10, 15 terabytes. And then when we look at data centers, or when we look at places where a lot of data is stored, when we look at these new companies, which are millennial companies like Facebook, LinkedIn, Twitter, wherein everything is about data, they have multiple backup devices, multiple types of data which are stored across different locations in order to have data available, and data is backed up, and we are talking about petabytes there, and that is something which you see as a concept within something called data centers, wherein tons and tons of information is stored on hardware devices, and a terabyte as a unit is also, in terms of its measurement, quite small with regards to, when we look at data warehouses, which store, I would say, I want to use the right word, tons and tons of information, from different consumers, different types of information, but they also have backup of these available so that if the system is to crash or the server goes down or the hardware fails, then the backup of that data is also clearly available. Now, looking at very briefly, the second part, which is looking at hardware in terms of, input-output devices, I think these devices have not primarily changed over the years. Obviously, styling, the the type in which they are designed and created has changed. But initially, when you had a mouse, you had only a left click, then right click was introduced, and then you have, the touchpad, which has also come out, and touchpad allows a lot of different gestures and a lot of different types of commands to be, integrated from an input device. In some of the touchpads that you see, or slates which people use when they attach it, like a digitizer, some of the graphic guys use, they're able to use a pencil which kind of is connected to the your tower unit or the CPU, and then allows that input to go across in terms of a graphics design. So when you look at engineers using, graphic designers, engineers using, complex softwares like AutoCAD, CAD and CAM, you look at graphics software, they use multiple input devices. So keyboard and mouse have not really changed, but there are other variants of mouse which have also got introduced. So these variants include things like trackpad, trackballs. For scroll, initially there was no scroll in the mouse, but slowly and gradually, as innovation has happened, technology has kept pace with adding new sets of instructions to a device. We do see now virtually every mouse has a trackball. In some cases, when you look at Mac devices, it simulates the movement of your finger or the palm of your hand, and that allows you to control, some of the input that you're doing to trying to put into the device. Now, there are alternative methods of input, and these methods of input typically use things like, devices in hand. So there are lots of things which can actually capture signal. So when I say systems component and hardware, I look at also gaming devices like Xbox and PS4. And what we do get to see is that, this is something wherein Bluetooth as a method of connectivity is coming, and we don't no longer see wires. And because of the connectivity, which is possible now through Bluetooth or proximity connectivity with these hardware devices, you see different forms of input devices which have come in, like the VR glasses. You see, game pads and those kind of things, which allow you to also provide input into, the systems. And obviously, I mentioned, when you look at tablets, you look at digitizers, you look at touch screens, they have also now allowed the integration of, gestures which allow you to actually use your fingers or touch screens to be able to control instructions onto a computer system. Is that okay?
Yes, that's okay.
Okay. In terms of, output devices, we look at different types. Very briefly mentioned here, you have monitors, printers, speakers, plotters, multimedia projectors. You have all output devices which could also allow you to add a storage device like an extender, or say like a micro SD card or a card reader, which could be in the machines. You look at external devices or output devices which allow you to take an output to like a video wall. So you have a video display unit which is connected, and that allows you to kind of take this across into multiple screens. Sometimes you also look at output devices now which allow you to magnify sound or the output which is coming out. So you could put in like a 2+1 speaker system, 4+1 speaker system to a PC, and that allows you to get different variation in terms of outputs. In terms of, in this case, maybe the output in terms of voice or the audio, and that is also dependent on the capability of the graphics card or the audio card. So if I want to plug in a digital Dolby system to a PC, which some of the gamers do have, they also look at Bluetooth connectivity. They look at the main system being connected to a optical fiber port rather than an audio port, because you don't want the sound card to blow off, and the sound card has to have certain type of capacity to be able to support those number of speakers. So output devices have also become complex over the years, and you used to have something called a VGA, which is
VGA camera.
Yeah, a camera as well. That is also an output device, which is so like a
what is it? I'm trying to disturb, but what is actually VGA? Like, what is actually VGA?
VGA basically is video graphics array, and video graphics array used to be an output port which is still prevalent in a lot of monitors, and that is a port which is required to basically convert your signal or the information coming across from the tower or the CPU into a display device. This has changed over the years into SVGA. super video graphics array, and that has allowed your resolution in terms of the monitor or the graphics card's capability to reflect onto a display screen, because sometimes you have a excellent graphics card which can display say 16.7 million colors, but also in terms of resolution when we say dots per inch. But over the years, as the graphics array in terms of the connectivity which allows this output to come out from the CPU has increased, what we have seen is the change in the upgrade or changes also coming across to how this information is displayed. So what we do see that VGA changed to SVGA, has changed to XGA, and depending on different types of devices, you have these ports integrated into these devices for having the relevant output for you to have on a display screen. So when you look at projectors, you have SVGA, XGA. When you look at monitors, is normally SVGA. Like in my case, if I look at the Mac, and if I look at going into About Us, and I look at display storage, you can see this has a 512 graphics card, and obviously the built-in display allows this resolution. That means these many dots are formed in terms of length and breadth of the monitor, which makes the appearance of an image or any sort of information which is being displayed on the output much more clearer, brighter, and better. Now, going into something like peripheral devices, there are different types of peripherals, input, output, as I mentioned earlier, and they've not really changed over the years, but things that have come in and disappeared. We do see zip drives, which were earlier available from a lot of different manufacturers. They used to allow you to store data which could be easily transported, or it made the data mobile. But at some stage, these were essentially storage, additional storage peripherals, but they've disappeared as we see over the years. Mouse, keyboard, printer, monitor still remain. Scanner have become integrated with printers nowadays. Most printers are, what is called the MFP, or multiple, they have multiple format printers, MFPs as we call them. And the reason why we call them is they are not able to just print, but they are also able to scan, and they are also able to have a facility called a fax in some of them. So you can send faxes across, or pieces of data across to a fax directly from your computer system. And in some cases, when you have senior executives, they would want a machine which is an all-in-one, as they say, a multifunctional device, MFD. And that is, again, a type of a peripheral device which allows you to print, scan, black and white, and color. So obviously variations in terms of what kind of output you want, but also has integrated functions of, something called a fax. Most devices on the printer side today have something called an ADF, or an automatic document feeder. That means if you have to scan a number of multiple pages, you can put it into the ADF reader, and it allows you to do that scanning, automatically, or for a certain set of pages automatically. Over the years, what we've also seen is that you have something called.
I'm sorry, I wanted to sorry, I want to interrupt, but then, what are internal devices? Are you talking about like CD-ROMs, like something you put in the computer, or internal devices are like your internal hard drive? Are those your internal devices, like a graphic card or something?
Well, in terms of both the things that you've said is correct. When you look at internal devices, it could be graphics card, memory, motherboard, power unit, which is inside the tower. But when we talk about peripherals, which are basically output devices, but they can be inside the tower, would be called internal peripherals. So things like our CD-ROMs, writers, internal modems. We don't have modems anymore, but because most of the machines have wireless now, or Wi-Fi available, and in some cases, some of the developing countries still have what you call the the dial-up connections. Then in that case, you'll have something called an internal modem, which allows you to plug in a telephone line or a fax line behind the PC or the tower, or that is where these devices are called internal peripherals, because they are basically going to be sending out an output or providing you an output, but because they are internal to the tower, they are called internal peripherals. But when we look at internal devices, those devices would be devices which are basically making the tower or the CPU work. And those could be things like your memory, your graphics card, your power supply, your motherboard, your sound card, because they are internal to the configuration of the machine or the hardware. Is that okay?
Yeah, that sounds good. So external hard drive are like your mouse, probably your headphone jack, your headphone. I'm just saying, mouse, headphone, charger. Just saying, just because you try to.
Peripherals, yes, external peripherals.
Yeah, and stuff like a USB port, like USB cable for a phone. So those are output devices, though.
They are for devices, and they are part of they are integrated onto the motherboard, so they are a part of your hardware, and that is where they will be classified as internal devices or things which are internal to the tower or your CPU.
So the motherboard, the internal hard drive, the internal hard drive, sound card. So these are So whatever it is in the computer, like in the casing, I would just say, just let's just say the computer has a casing.
Yeah.
So pretty much whatever is in that casing, it's considered internal, and whatever that is not, that it's not in the casing, it's considered external, right? Just want to just get it.
In some cases, what you will see is in the earlier towers, there were multiple bays available. So you had one hard drive. As the towers and the systems evolved, what we got to see was that there were at least 3 or 4 bays available in the tower in terms of the height. Because sometimes initially when they came out, the towers were horizontal, but at a later stage, you had the option to pick a horizontal or a vertical tower, and both these towers, had what you call multiple bays. So in the multiple bays, you could install internal devices or peripherals like CD-ROM, DVD-ROM. Sometimes, if you look at the early 90s, people used to buy a DVD-ROM and also buy a CD-ROM. And they were different bays. They were installed in different bays. Also, when you look at multiple bays, some of these bays in the tower were used to install more than one hard drive. So if you had to expand your system or expand your memory, you never checked out your basic primary hard drive because the hard drives at that point in time were very expensive. So if you bought the initial system with 30 gig or a 20 gig hard drive, you never threw that away. But in order to expand it, you had an additional bay which was empty. And what you used to do is buy an 80 drive which was available at a lower price or at a new price when it was introduced. You install the 80 gig and you had 80 plus 30 or 80 plus 10 gig in the computer, making your overall memory higher. So depending on how they were installed, if it was internal and becoming a part of the tower, they were called internal devices, and they were integral to the functioning of the CPU or the tower itself, the computer system. But if there were devices which could be, taken out in the sense, could be portable, and then they were not necessarily required for the functioning of the basic system, then they were called the peripherals, and these peripherals were classified as zip drives, floppy drives, CD-ROM drives, DVD-ROM drives. To a certain extent, you had things like speakers, which were external, modems, which were external. So before the internal modem came about, there used to be an external modem which used to be connected to one of the modem ports at the back, and that allowed the telephone line to be connected. But because it was external, it was a peripheral. But when it became internal, it was still a peripheral, but we had the option to integrate that internally or externally in order to save space. And that is where the classification, comes about when we talk about peripherals and we talk about devices. Okay. Now let's look at broadly going into networking. Now, as you know, the complexity of computer systems, has increased or has become multifold in terms of capacity, storage, transfer of data and information. What has happened is that there is another side of things which started to happen is that when we look at of internet in 1995, when Tim Berners-Lee introduced the internet, even prior to when he introduced this for the public, the US Army was actually using 2 systems which they had created for file sharing. They were ARPANET and DARPANET. Now, these were essentially to save, share information East Coast to the West Coast between the, say for example, government departments, and particularly used for military purposes. That technology, when we get to see public,
So WAN is more for so WANs are more for like servers. Like I'm just trying to think of gaming servers. Say for example, a gaming server, like like a gaming server say for instance someone's playing a shooting game, and like a gaming server that if they're trying to the server will work good for only the people in that specific area. If other people from another part of the world trying to join that server, it's not going to have a little bit of consistency and connection, because there's more of like there's more flaws. So I mean, is that WAN like a server, like a gaming server, like people trying to join and they're like other people trying to join and they're like the people in that area would get more will get the priority, the priority connection, I would say, compared to the other people who are trying to join. Is that it?
That is true. That is a revolution which came, primarily, I would say, in the early 2005. But when we look at the evolution of networks, primarily they started off as networks between different computer systems, when we look at the concept of sharing of data led to the creation of networks. So we see this happening in the early 1990s with the US military using it. Then it came across to when Tim Berners-Lee introduced HTML, hypertext markup language, and that led to the creation of something called the internet that we end up using today. But that is a type of a network which is a public network, a network which allows transfer of information, via different formats. But when we look at the hardware side of things start off with something called a hardware network, and these are classified in different types. So when you have a network, that means two or more PCs connected in a particular location, that led to the creation of something called a local area network. That means 2 or 3 PCs or components, computer systems were connected in one location, under one roof, in one office, in one room. When the creation of wide area network, that means 2 opposite buildings or areas which were slightly far apart could have been connected using cables, but there were 2 different systems or 2 set of systems operating in different locations, and they, when connected together under some sort of a coverage, led to the creation of something called wide area network. Now, and then after that, if you add number of systems, as you're saying, if you are a gamer, an example of that would be that you're trying to connect to a public service system, which is either on the cloud or based somewhere else, and a lot of users are simultaneously trying to use it. That led to the creation of something called MAN, Metropolitan Area Network. That means a lot of users could be serviced at one point in time by that network because they were trying to seek or source different types of information, which could be either shared or requested from different types of computer systems. And then when we had the advent of wireless technologies, it led to the creation of something called the wireless local area network, which today we get to see in our houses. So you have the internet or the service provider sending you, basically coming in from, let's say, your local provider like BT in the UK or Virgin, for example. And what you tend to do is you want that connection to be spread across into your house. So you plug in a wireless router, which allows you to create a local area network, which is still controlled, password protected, encrypted network, but working with your own confines for your devices. And that normally is called the wireless LAN or, something called a VLAN. Now, there are other types of networks. So when we talk about gaming networks, that is an example of something called SAN, because here there is a central system which is installed, and that system services a number of gamers or a number of networks or computer systems which are connected. And the capacity of SAN or these type of networks also is dependent on where they are installed, how quickly they are serviced in terms of the internet bandwidth, and how quickly they are able to bring that information across to the user. And then we had CAN or campus area networks, which were essentially set up in universities or closed public places wherein they wanted a control network to share data or information across different departments. That led to the creation of something called CAN. Personal networks which people can set up between 2 offices, 2 sites, 2 houses. That is a bit of an extension of your a local area network, but because it's in.
I'm really sorry. Can you give me like 2 minutes? I need to go to the bathroom.
All right. Okay. Go for it.
I'm sorry. 2 minutes, please.
Okay. हाँ समीर बताएं। हाँ तो ठीक है, उसको हैंडल करो यार, उससे बात करो, उसको अपने पास रखो। मेरी क्लास ले रहा हूँ अभी, तू नोट कर दे यार, मैं आ रहा हूँ ऑफिस, उसके डिस्कस करने की कोई इशू नहीं है। एनी कॉल आ रही है उसको नोट कर ले मैसेज कि आई एम करंटली बिजी। इफ यू मैंने आज न्यूज़लेटर भेजा है तो ऑब्वियसली बिकॉज ऑफ दैट लॉट्स ऑफ थिंग्स वुड बी कमिंग। काफी लोग वेबसाइट पे जा रहे हैं, तो they might be calling. Don't worry, take the messages down और मैं आके डील कर लेता हूँ. ठीक है, चले.
Okay.
I'm so sorry. So sorry. I'm here.
Alright, okay. So
sorry. So
sorry.
Well,
So what we were looking at briefly was primarily going through, different types of network infrastructures. Now, some part of this is a bit of reading. Now, like we looked at the computer systems, which is internal, external, hardware, storage, input-output devices. Similarly, when we look at different types of networks, there was a reason or logic behind it why this was introduced. So network infrastructure, when it was introduced, also constitutes hardware and software. So when we look at type of, designing of type of network, why we called it a LAN, why we called it, metro area network or wide area network, they were designs or topologies which were actually created, the technical term being topology, which was actually created to be able to allow certain types of data, content, information to be shared across PCs or systems. And to run this network, there is a requirement of creating a network infrastructure, and that includes a combination of hardware and software. So when we look at software, we basically talk about things which are related. When we talk about, say, hardware, for example, in order to put together a network, you need things like routers, switches, LAN cards, wireless routers, or cables. So when we talk about cables, you have cables which are type Cat5 type. The reason why they say Cat6 type. Now they had the capacity. They were basically made up of copper. As the material is improved, it allows more data at higher speeds to be transmitted. So Cat5 were basically cables which allowed data to be going at kilobytes per second. Cat6 is gigabytes per second. So megabytes and gigabytes. So today most of the networking which is happening in terms of cabling that we do, in terms of creating an infrastructure to lay down a lot of cables. So if I, as a layman, understand how does a network work, I don't see a lot of wires or under the, floors of, a lot of offices within the floors. You have a lot of wiring which goes on, which allows different systems to be connected. Some part of this is wireless. That means the endpoint connectivity, where the network is then made available to users or employees to use. That could be wireless, but in most cases, when you have a permanent desk or an office, you normally have something called a wired network, and wired network constitutes of in order to create that, you basically look at some hardware. So hardwares it required would be things like switches, LAN cards, which have to be in the system to be able to get that system onto a network. Sometimes you will also see intelligent switches which have the ability to be able to control traffic, or basically self-diagnose problems are also now available. But basically, in a sense, what we are looking at understanding here is, when we look at a network consists of hardware and software, and as the hardware required to run the network has increased and has become more complex, because you can have one local area network, one office location, for example, and you have 60 PCs connected to it. Now, they are not just peer-to-peer networking. That means each of the PCs is not connected to all the other PCs. They are all connected to a central system, which basically does the monitoring, routing of traffic, maintaining the load, and also allowing certain part and access to the data which is shared across the network. But at some stage, in order to create this complex network, which has 50, 60, 100 PCs, or even 200, 300 PCs in one installation on a single floor, you would need a lot of networking hardware to basically make it work, because the signal in some cases would drop. You can't just have the signal going through wires. At some stage, you need boosters. You need hardware to be able to boost that signal. And that hardware, when we look at the type of hardware used to create network, the basic starts with cables. Cables are connected to switches. Switches are connected to, obviously, in some cases, servers, or, when we look at some of these switches could be connected to routers, because routers allow the routing of data and the traffic to be monitored by somebody who's sitting in the network operations center, as we call NOC. The person who maintains, keeps the network running, will have access to all the hardware and is able to do some of these things remotely. And that is where we do see software coming in. And when we look at a number of systems onto a particular network, running simultaneously, pulling out a lot of data in order to look at maintaining load, to making sure the traffic flows, there are no problems. Access to data is, only given to people who have rights to be able to access. And then obviously no external systems are able to access that data, requires putting in of a lot of softwares. And these softwares could be things like, when we talk about the network operations software or management software, which used to be available, the earlier versions of that was introduced by Microsoft in the Windows 2000 server, Windows 95 server, and that allowed some of these systems connected on the network to be controlled remotely, or maintained remotely. That has also increased, and over the years, this has led, in terms of evolution, new features, functions have been added. Microsoft created something called the MSDN network, which is Microsoft, data network, and that had, ability for the people working within IT departments to do troubleshooting and refer to, repositories of data in case if there's a problem which occurred, then how to resolve. And those data networks allowed, were open and obviously shared across with network engineers or people who used to work on maintaining networks. And we still see that today. So the 95 server went to 98, 2000, 2008 server, and what we have today in modern day terminology is Windows Server, or something which allows, systems management software, as we call it, SMS, which is now integrated in most servers, and it allows people who understand networks to configure networks, maintain them, operate them, and for which you require different types of software. Softwares like firewall security, you have network security applications, you have different operating systems running in this office. Practically, if you look at it, there are offices which are now more or less having different types of systems. Some of them will have access to tablets, touch PCs, traditional PCs, Macs. And when you have all this different type of network, different type of hardware on a network, you need a software to be able to maintain and, kind of service the requirements. And in those cases, network people who understand, network engineers, people who are qualified with Microsoft technologies, Cisco technologies, have to be able to understand how to use these softwares. So a network in general, broadly speaking, when we talk about different types, we looked at, LAN, MAN, WAN, different types of networks. But in order to run those networks, you need hardware and you need software. And that is, just a bit of classification that you need to understand in this unit. Then one or two small slides to primarily understand why do you need a network software. If you have 20 PCs running in a place and 20 PCs are servicing different types of different types of requests with different type of, I'm browsing the internet, somebody's working on Word, somebody's accessing data from the server. When you look at all that, you need a software to manage performance or, monitor performance in terms of bandwidth usage. Like sometimes in the offices, you have network operators sending out a flash message saying, please do not download movies, or please do not download, software, or, pirate software. When these kind of things happen, what you do see is that the computer, which starts to download heavy amount of data, starts clogging up all the bandwidth. So that is where, you will see one application of how networking software is used to manage, basically monitor performance, manage bandwidth, and then basically only the systems engineer sends out a message, has the ability using the SMS software to basically send out a message to that user saying that could you stop using that, or you could block that application remotely. In some offices, you see that the use of Facebook, Twitter, other applications are not allowed is because they seem to be interfering because HR or the company policies do not allow access to some of these sites within the office hours. And that is where the network engineers or the people who manage networks have the ability to block it at the source by blocking some of the IPs for some of these, websites and, services. So in general, the first learning outcome, basically facilitates you to understand what is a computer system. When you look at multiple computers working in a particular area and a network is formed, understand what is the networking infrastructure, how do we analyze and understand the functions of different type of components in the system, input, output devices, peripherals, things like that, and how do you see today some of these peripherals meeting the demands of different type of consumers working within an organization. So if you look at an example here within the NHS, the National Health Service in the UK, or a large multinational organization, say Samsung, you will see a lot of executives carrying tablets. You see a lot of executives carrying mobile phones. You'll see mid-junior management having, mid-management maybe access to laptops, Macs, and then you see junior management people or people working within the front-end services having access to PCs or, CPUs, which are primarily fixed desk machines or computer systems. Now, when you look at understanding different types of systems being used within an organization and the purposes for which they are being used, you will see that, you will need to know very clearly that in order to put it together, you need to have a good understanding of how these systems work, why these are used, at what level they are used, and if they are all working together under one roof, then you need a network, to be able to manage them so that there is no data breach, there is no, for example, unauthorized access to some of the information the system has, and that is where networking software, and those kind of things start to come in. So the first learning outcome, understanding the basics of hardware from a standpoint of view of computer system, and that would enable you to kind of add on to some of the basic knowledge that you see that we put together on the PowerPoint slides here. Now, if I close that for a minute and draw your attention towards 2 or 3 videos which I put in. These are 4 or 5 minutes videos that you can watch. One is what is a network and network infrastructure. This is a good video to watch. And then the second is just to quickly recap on the types of what makes a computer system. So when you look at that, this is a good video that I put on, obviously, for you to look at, which will help you kind of easily summarize, the first learning outcome. Is that okay?
Yeah, that's fine. Actually, I got to go for now, but yeah, I'll definitely look into it. And is there any way I can refer back to this lecture you just had right now?
Yes, you will get a copy of this recording in a couple of minutes, and Samit will forward that on to you. And you will see that recording coming up on the system here as well.
System as in
yeah, on Moodle. You will see a recording link being put up here. But I'll ask him to send you an email on that as well.
I will. All right. Thank you so much.
Okay, no worries.